everybody. Let's give this op-amp problem a try. And this is an actual engineering problem because there's no one right answer. All right, so we're given this is our goal output voltage, but then this is our circuit. So let's solve for the output voltage in terms of IA and IB and then compare these two. Okay, so let's say I label this as node N over here, node P over here, and this is my output, right? So right, so let's write KCL at node N. So let's go, if current is positive going out, this is going in, right? So that's negative IA. And then the current going this way would be Vn minus 0 over Ra. And then the current going this way, Vn minus Vo over Rf. And then the current going this way toward the right, I'll just call that In equals 0. Okay, and then it says the op-amp is ideal. That means the voltage here equals the voltage here. Vn equals Vp. So this is one equation. Second equation, Vn equals Vp. And then also for an ideal op-amp, the current going this way is 0. That means this is 0. The current going this way is 0. I'm not sure that applies just yet, but let's see. Okay, so that is relevant because now that I'm looking at this circuit right here, maybe let me just draw that. Okay, so this is IB, and then whatever current is going this way and whatever current is going this way, right? If you consider KCL at node P, the current, let me just write that. So KCL at node P, negative IB plus Vp over 1K plus IP equals 0. Oh, this is equation 3 now. Okay, so for an ideal op-amp, this is 0. This is 0. Okay, so that means we have an expression for Vp. Let me just write that. So let's see. Vp over 1000 equals IB, and then just move this on this side. Vp equals 1000 IB. And then we just said for an ideal op-amp, Vn equals Vp. Right? And this can go right there and here. So let me just combine them right now. So plugging this in here and here. So let me rewrite this equation. Minus Ia plus 1000 IB over Ra plus 1000 IB minus Vo over Rf. Okay. And here we have V out as a function of my input currents. So let me just kind of clean this up a little bit. Let me split this up. There. Okay, and then I can move this on this side of the equation. There. Right, and then multiply everything by Rf. There. Okay, so now I have an expression for my output voltage. Let me just gather terms here. What do we have here? Minus RFIA, and then IB So that, oh, we can factor out 1,000. Okay, we can factor out 1,000 IB. 1,000 IB, and then what's left? RF over RA and 1. Okay, here we go. And what was our original? 5,000 IB minus IA. Let me just swap these around like that. And okay, and let me write IB over here instead. I just want it to look similar to our goal. 5,000 times IB minus IA. So this is from the circuit, and then what we're trying to get is 5,000 IB minus 5,000 IA. Right? 5,000 IB minus 5,000 IA. So already, if you compare, or here already, RF has got to be 5K, so that was easy. And then this has got to be equal. So let me just jot that down. 1,000 RF over RA plus 1 has got to be equal to 5,000. Okay, so let's divide both sides by 1,000. Very good. There we go, and then subtract 1 from both sides. And there we go. RF equals 4 RA. Or maybe the other way around. RA equals 1/4 RF. And then RF was 5K, so what is that? 1250? 1250, okay. All right, so RA we want to be 1250, not K, ohms, right? And then RF is 5,000 ohms. I'll just write 1.25K maybe. Okay, so that's what we want, but in real life, you can't, right? I got this table from the appendix. Okay, so we wanted RA to be 1.25K, and we wanted RB to be 5K. But there's no 5K, right? There's also no 1.25. There's a 1.2. And, right, so if you take 1.2 plus 50, there's no 50. Right, so you see what I mean? So how do we do this? So whatever it takes to combine to get these two. So for example, 5K. Let's see, you can go, you can take 5 of these in series, that'll be 5K. Or for example, you can take these two together, would be 4 and then 5. Right? So these 3 in series will make 5K. Or you could go 10K in parallel with 10K, like this. Right? That would be 5K. So lots of different ways to do it. There's some nuance to it that we can discuss later, because you have to keep an eye on the current. Okay, and then how do we make 1.25? Let's see, you can go 1.2, and then we need another 50, which there's no 50, but you can take 100 in parallel with 100, right? So like 1.2K, and then 100 and 100, right? Because that's 50, and then 1250. And then other ways you could do it as well. Okay, maybe that's enough, right? The point is there's all different ways to do that. Okay? So give this a try yourself. Let me know if you have questions, and I'll see you on the next video.